All right, we're diving into one of the biggest mysteries in science. What exactly is dark matter?
Take a look at the universe's recipe. See that tiny slice? That's everything we know and see.
That missing 27%? We call it dark matter. And honestly, we have no clue what it is.
Think of it like a cosmic crime scene. And right now, we've got a prime suspect.
These aren't your typical black holes. Nope, they're ancient relics, born right after the Big Bang.
So to get this, we need a quick background check. What is a black hole anyway?
Get this, inside the event horizon, space itself is actually falling faster than light can travel.
So it's not pulling you in. Spacetime becomes a one-way waterfall that nothing escapes.
Okay, but how could these tiny things make up all of today's dark matter? Well, it's a cosmic race.
Back in the early universe, you had two main players, radiation and matter, like these black holes.
As the universe expands, radiation thins out way faster than matter does. Its influence just fades away.
Which means even a tiny bit of these primordial black holes would eventually take over everything.
But here's the catch to this whole elegant theory. It required some insane precision.
You see, the amount of the universe that became these black holes had to be this small.
That's 1 part in a billion. Any more, the universe collapses. Any less, and no dark matter.
It was a total cosmic long shot, an incredible, almost unbelievable amount of fine-tuning. Okay, so what's the final verdict on our suspect? Let's recap the key points from the case file.
The evidence is compelling, but the circumstances are just suspicious. So, yeah, the case is still wide open.
So the jury's still out. Could the answer really be hidden in the universe's very first second?
All right, let's dive right in. Today, we're tackling one of the biggest and frankly spookiest mysteries in all of science. What if the answer to the universe's greatest unknown isn't some exotic new particle, but something that's been hiding in plain sight since the literal dawn of time? So to kick things off, let's set up our cosmic crime scene with one single question. I mean, look around. Everything you can see, me, the screen, the stars, all of it is just a tiny, tiny fraction of what's actually out there. So what on earth makes up the other 85% of all the stuff, all the matter in our universe? And this is where things get really wild. You see this chart? That giant 70% chunk is dark energy. And that's a whole other mystery for another day. But let's focus on the matter. The normal stuff we're made of, that's just this tiny little 5% sliver. The real heavyweight here, making up 25% of the entire universe, is dark matter. That means that for every 1 pound of normal stuff, there are over 5 pounds of this invisible substance. We can't see it, we can't touch it, but we know it's there. So here's our game plan for this explainer. First, we'll look at the clues for this missing matter. Then we'll bring in gravity's ultimate prison, the black hole. After that, we meet our primordial suspect and investigate its origin story with echoes of the Big Bang. And finally, we'll ask the big question, are we living in a universe of ghosts? All right, section 1, the universe's missing matter. So first things first, how do you know something's there if it's completely invisible? Well, the answer is pretty simple. You watch what it does to everything else. And it all comes down to gravity. And believe me, the fingerprints of this stuff are all over the cosmos. For one, we see entire galaxies spinning way, way too fast. I mean, based on the stars we can see, they should have just flung themselves apart billions of years ago. Something extra, something massive and invisible, has to be holding them together. Then there's gravitational lensing. The gravity from huge, invisible clumps of dark matter literally bends and magnifies the light from galaxies behind it, like a giant cosmic telescope. We can even see its influence imprinted on the very first light of the universe. The takeaway is undeniable. Dark matter is real, there's a ton of it, and it's totally dark. Okay, on to section 2, gravity's ultimate prison. Now that we've established our mystery, let's bring in another key player. Something we do know about, something that's also famous for being invisible and having absolutely mind-bending gravity. Yeah, you guessed it. We're talking about black holes. Now, the normal black holes we usually hear about are called stellar black holes. You probably know the deal. A massive star, way bigger than our sun, runs out of fuel and collapses in on itself. The result is a spot in spacetime with so much gravity packed into such a tiny space that nothing, not even light itself, can get out. It's the ultimate one-way street. But here's a mind-blowing way to think about why nothing can escape. This quote just nails it. It's not just about speed. Imagine a waterfall, but the water is the fabric of space itself. Once you cross the edge, that's the event horizon. The current of spacetime is pulling you in faster than you could ever hope to swim out, even if you were moving at the speed of light. You can't outrun reality itself. So this process, big star, runs out of gas, collapses, maybe a supernova, bam, black hole. This is how all the black holes we've actually detected are made. They're the corpses of giant stars. But, and this is the big question, what if this isn't the only way to make a black hole? And that question brings us right to section 3, a primordial suspect. This is where our cosmic detective story really heats up. Because what if the answer to dark matter isn't some exotic, undiscovered particle? What if it's just black holes, but a completely different kind, an ancient kind? I want you to meet our prime suspect, primordial black holes, or PBHs. You gotta forget everything you know about normal black holes, because these guys are a whole different beast. Their source isn't dead stars, it's the Big Bang itself. They weren't formed recently. We're talking the first second of time. And their size, they don't have to be huge. They could be as small as an asteroid, maybe even smaller. So the theory itself is beautiful because it's so simple. It just asks, what if dark matter isn't a new thing we have to find at all? What if it's just a gigantic, invisible swarm of these ancient black holes left over from the creation of the universe, silently filling up all that empty space? But is that even possible? I mean, how could you make a black hole without a star? Well, for section 4, we have to go back in time, all the way back to the ultimate scene of the crime, the Big Bang. Let's check out the origin story of our suspect. Okay, try to picture the universe when it was less than a second old. It's not a calm place. It's a chaotic, unbelievably dense soup of energy. And it wasn't perfectly smooth. There were tiny little ripples, some spots that were just a fraction denser than others. The idea is that in a few of the most dense spots, gravity was already so powerful, it just won. It crushed that little patch of universe down into a black hole on the spot. No star needed, just pure, raw density from the beginning of time itself. All right, that sounds pretty plausible, right? But it does beg a huge question. We need a lot of dark matter to explain what we see today. So just how much of that early universe soup would have needed to spontaneously collapse to create enough of these things? And the answer is what makes this theory so dang compelling. Get this. You would only need about 1/billionth of the universe's mass to collapse. That's it. A tiny, tiny fraction. It just goes to show you how absolutely insane the conditions were back then. A minuscule hiccup, a 1 in a billion lump in that primordial soup, was all it would take to cook up every single bit of dark matter we're still looking for today. Which brings us to our final section, our universe of ghosts. We've seen the evidence, we've met the suspect, we've heard the origin story. So, what's the verdict? Is this our answer? You know, the case for these primordial black holes is actually pretty strong. The best thing it has going for it is its elegance. It doesn't need any new physics or weird undiscovered particles. It just uses black holes, which we know are real. They would have formed super early, which fits our models of the universe perfectly. They could even explain some of those strange gravitational lensing events we've seen. And here's the real kicker. They might also solve another huge mystery, where the supermassive black holes in the center of galaxies came from. Maybe they just grew from these primordial seeds. You get a 2-for-1 deal. Now, the jury is definitely still out, but this is one of the hottest areas in cosmology right now, for sure. So I'm going to leave you with this thought. The next time you look up at the night sky and you see all that blackness between the stars, just ask yourself, is it really empty? Or could it be that we're all just swimming in an invisible ocean of ancient ghosts, cosmic fossils from the very first second of creation, whose collective gravity has been quietly shaping our entire universe all along? Makes you think, doesn't it?